This video introduces the Bundy reciprocal system theory, BRSt, which is a new quantum theory of fundamental physics. It is based on Dewey B. Larson's reciprocal system of physical theory, or the RST. It is a system of theoretical development that deduces the consequences of two fundamental postulates. First, that the physical universe consists of one component, motion, existing in 3 dimensions, in discrete units, with 2 reciprocal aspects, space and time. The second postulate is that the physical universe conforms to the relations of ordinary commutative mathematics, its primary magnitudes are absolute, and its geometry is Euclidean. Fundamental physics research begins with the nature of light, mirroring the biblical account of creation. Modern inquiry into light, stemming from observations of the rainbow, has led to a wonderful understanding of light, but some mysteries still remain. We can build lasers, we can communicate with light, we can compute with it, but we still don't know many aspects of its origin and its full nature. Of course, mathematics became a major tool for the systematic investigation of light's properties and behavior. With mathematical tools, we have built telescopes to study the light of the stars and galaxies and the clusters of galaxies, stretching back billions of years. However, the discovery that a wave of light also behaves as a particle introduced a significant source of confusion. How can something spread out like a wave and yet act as a localized point or particle simultaneously? This puzzle has stumped theoreticians for 100 years. In the double-slit experiment, waves passing through the slits leave small dots on the screen, creating interference patterns due to waves overlapping each other. Even more confusing, it was later found that particles, such as electrons, also behave as waves, leaving overlapping wave patterns of dots on a detector screen. Researchers found that light interacts with particles, where each atom has a unique pattern of emitted and absorbed light, like a fingerprint. Niels Bohr modeled the atom as a positively charged nucleus, orbited by negatively charged electrons. He used the number 4 in the form of 2 squared equals 4 to construct a model that worked perfectly for hydrogen, showing how levels of light were emitted and absorbed when electrons changed their orbits, the quantum leap. Later, Werner Heisenberg used Fourier transforms to analyze the light, and this time found that the number 4 led to an uncertainty principle. This suggested that light patterns were related to the ratio of Planck's constant and the number 4, a revolutionary idea. Paul Dirac used Heisenberg's work and the number 4 again, in the form of 4x4 matrices representing space and time, to make the wave equation consistent with Einstein's theory of special relativity. This launched the new quantum mechanics, replacing orbits with clouds of electrical charge around the nucleus. With Dirac's work in hand, the developers of today's quantum theory were able to posit that the observed particles and their behavior could be explained by assuming that each particle is a perturbation of a field of magnitudes that exist everywhere at once. This concept is called quantum field theory and has been used to develop the standard model of particle physics, even though it is built on the field concept of waves, not particles. The standard model of particle physics, built with quantum theory, works very well, but doesn't have answers for many questions, like where do the particles originate? What causes a particle wave to change to a particle point on the screen? Why do particles not have mass that gravitates? And there are many others. Enter the late Dewey B. Larson, an independent researcher of fundamental physics. He introduced a new physics based on scalar magnitudes instead of vector motion. The standard model physics only uses scalar magnitude to scale vectors, but Larson's physics uses scalar magnitudes in their own right. This changed everything. But, again, it is the number 4 which plays the central role. This time, however, its true fundamental nature is finally revealed. To be continued.